Welcome to part 2 of the Unit 3 Quadratic Functions Review. In this part, we're going to take an in-depth look at some of the more difficult problems from this unit. But first, I'd like to give a quick shout out to the Explain Everything crew, who have designed such an amazing interactive app that even you can use to make your next class presentation. Now, let's get started. Let's start off with everyone's favorite question. If we look at page 178, number 12, let me just read this. It says, Jackie mows a strip of uniform width around her 25 meter by 15 meter rectangular lawn and leaves a patch of lawn that is 60% of the original area. So what this is indicating is that Jackie's rectangular lawn originally is 25 meters by 15 meters. And she's going to mow a patch of lawn around the outside edges of her original lawn, leaving her with a smaller lawn that is 60%. This green shaded area is 60% of the original area. So she mows uniform width along the inside borders of her lawn. So that means that this right here, because they are asking us, what is the width of the strip on the outside? Well, if it's all uniform width, that means this is the same as that, which is the same as this here, and which is the same as this here. That's all uniform width. They're all the same. So we can call that something. We don't know what that is. That's what we're trying to find. So everyone likes calling it X, so we'll call it X. That's an X, that there is an X, that there is an X, and that there is an X. We don't know if that's one lawnmower length, two lawnmower lengths. We have no idea. That's what we're trying to figure out. So this is the drawing that we have here. This is what we know so far. And we know that this green shaded area in here, this green in here, is 60% of what her original rectangular lawn was. So let's come up with an equation to figure out the area of the rectangular lawn, the green shaded part. Now the area of any rectangle is whatever the length is times whatever the width is. But we can actually call the length and width something here. See, if we know that the length, is this part right here, if that's the length right there, if we call that the length, that blue line here on the outside edge is less than 25. We know that this big distance, this big length from here to here is 25, okay? But this blue from here to here, this blue, or even this one up here, that blue there is less than 25. How much less than 25? Well, you can see that if this long length here is 25, they've shaved off an X on each side here, which means that this length here is almost 25. It's 25 minus an X from both sides. So it's minus 2 of those X's. That's going to be the length of that rectangle. So that inner rectangle is going to be 25 minus 2x. Now the width, on the other hand, the width, we'll draw the width in red. So this is the width here. So that width right there, that is almost 15. Well, it's not quite 15. 15 would be all the way from here to here. That's the original rectangle was 15. But again, this width right here, this red line, it's almost 15. They shave off an X from both sides. So of course, this width, which is from here all the way to here, is going to be almost 15, but they shave off an x from both sides. So 15 minus 2 of those x's. That will be the width of that new rectangle. So for width, we can write 15 minus 2x. Now, that's great, but we also have to know what the actual area of that rectangle is. I'd like to write something in here for A. So how do we figure that out? Well, we know that that area is actually 60% of the area of the black rectangle, the outer rectangle. Now, the outer rectangle is very easy to come up with the area of the outer rectangle. The area of the outer rectangle is just going to be the length of the outer rectangle, which is 25, times the width, which is 15. And when we do that, we get 375 meters squared. Okay? And so we know that the area of the green, as the question states, after she mows this strip, she leaves a patch of lawn that is 60% of the original. So 60% of that. So the way we find 60%, 60% as a decimal is 0.60, and you're going to multiply that by 375, and you will end up with that the area of the green would be 225. Okay, so instead of writing A up here, we're going to write 225. So this thinking problem, by the way, this was a thinking problem because there was a T there. This thinking problem, we have to make it look like more of a more difficult knowledge question. This formula right here is nothing more than a pretty difficult knowledge question. We have to solve for x when we have this equation. How do we solve for x? Well, the first thing would be that we put that entire equation into standard form and then solve for x. We can either solve for x by factoring or by using the quadratic formula. So when I multiply this all out, 25 times 15, I'm going to get 375. 25 times negative 2x is negative 50x. I have negative 2x times both of those things. Negative 2x times 15 is negative 30x. And then I also have negative 2x times negative 2x, which is positive 4x squared. Okay, so how do we solve a quadratic? We bring everything to one side equals 0. So I'll write this in descending order, 4x squared. And I'll actually add those two things right there right now. Negative 50 minus another 30 minus another 30x is negative 80x. We have this plus 375. And I'm going to bring the 225 over to the other side, which would be negative 225, leaving me with nothing on this side. Continuing this, I have 4x squared minus 80x, and when I add those two things together, I get positive 150. So in actuality, this is nothing more than a basic knowledge question if we can get up to this point here. And obviously, setting up this problem is the more difficult task. Now, there are other examples of this actual question. I actually give that example in my lesson for this section. This is 3.5, so you can look at the 3.5 lesson. I have a picture frame question there. Otherwise, you can look at page 175, and it is example 3. And they have a different type of question that involves a factory on a lawn. Now I'm going to actually erase all of these drawings here, and I'm going to actually solve for 4x squared minus 80. This thing right here, I'm going to solve for 4x squared minus 80x plus 150. So I erased all that, and I'm going to solve for this. Now, in order to solve for this, we can either use the quadratic formula or we can factor. I actually noticed that everything here is divisible by 2, so that's what I'm going to actually do first. I'm going to take out a common factor of 2, leaving me with 2x squared minus 40x plus 75. That's not to say that this thing is factorable. This thing could be not factorable. Who's to say that this x value is an actual whole number? I would probably put my money on the fact that it is not. So I'm actually going to use the quadratic formula for this thing here because I just tried it in my head and I know that's not factorable. So we know the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this is solving this or finding the zeros here, right? Finding when the quadratic is equal to 0. And so I'm going to use that my a value is 2. I'm going to use my b value is negative 40 and my c value is 75. Sir, how about if I use these numbers up here, 4, negative 80, and 150? We'll still get the exact same answer. Remember, these two equations are still the same. So if I continue this is x equals negative, and then my b is negative 40, so be careful there. So negative and then negative 40 plus or minus the square root of, then I have negative 40 all squared minus 4 times a, which is 2, times c, which is 75, and then all over 2 times a, which is 2. Continuing this, I'm going to get positive 40 plus or minus the square root of, this is 1600, and when I multiply negative 4 times 2 times 75, I get negative 600, I think, all over, yeah, it's 600, all over 4, and so x is equal to 40 plus or minus the square root of 1600 minus 600 is 1000 all over 4. Okay, and we can break it up at this point, and there's no need to actually reduce this right there. We don't have to reduce that because we're actually figuring out what this strip is in terms of the actual length. Now, I'm not sure what the question asks us to round it to, if it even does ask it to round it to anything. I don't think it does, but that doesn't matter. So we're going to break this up into 2. We're going to get x equals 40 plus or minus the square root of, actually just plus the square root of 1000 all over 4, or we have x equals 40 minus square root of 1000 over 4. Okay, so then when we do both of these separately, I'll give you a minute to do that. The first answer you should get is 17.90, so we'll say 17.9. And the second answer, you will get 2.09 something, so I'll just round it to 2.1. So those are my two answers. Now, this is kind of weird because normally in a question like this, a situation like this, one of our answers would be negative, and so we can cancel out the answer that doesn't make sense, which is negative. However, in this question, both of these answers are positive numbers, so can it be both? Well, let's take a look at the original question here. I mean, maybe one of these things don't make sense. I mean, does 17.9 actually make sense? Well, looking at the picture here, I don't think 17.9 makes sense, because if this side is 15, how can this little bit be 17.9? That's impossible. It's impossible for that to be 17.9, because that would mean that this is also 17.9. But we know that this length from here to here is only 15. And you could make the same argument for this side as well. So that actually is inadmissible, that answer. So the only answer is 2.1 meters. Therefore, the path that she mows of uniform width is 2.1 meters. Let's now turn back to the review on page 203 and look at number 18, which a lot of you have been asking me about. So it says determine the equation of the parabola when you have roots 2 plus root 3 and another root 2 minus root 3. And it also says that it passes through a specific point of 2, 5. So we know that this point works on the parabola. It doesn't mean that this point is the vertex. In actuality, it probably is not the vertex. But we do know that these are the roots here. Right here are the roots. So it doesn't say anything about this point being the vertex, okay? It doesn't say this is the vertex. So please get that out of your head. It's not the vertex. Well, it could be, but we're going to assume it's not. Now, if those are the roots, we know that the formula for any parabola that is in factored form is y equals a x minus r times x minus s. So x minus the first x-intercept times x minus the second x-intercept. Be careful. This entire thing is the first x-intercept, and this entire thing is the second x-intercept. So we have y equals a x minus, be careful, I'm going to write brackets in here, 2 plus root 3 is my first x-intercept, okay? And then x minus, and my second x-intercept is this whole thing, 2 minus root 3. Okay, so this is actually what you should be writing here. Now, continuing this, I'm going to make sure I expand this negative here. So simplifying a little bit, I have x, and the minus applies to both of those things in here. So I have minus 2 minus root 3. That's the first bracket. The second bracket, if I apply that negative to both things, I have x minus 2 plus root 3. Okay, so this is my formula thus far. This is almost the formula. But in order to get the full formula, I have to figure out what a is equal to. That is very important. So the only way I can figure out what a is equal to is if I had another point. If I had another point on this parabola, I can plug that point in and figure out my a value, and then I'll rewrite this line right here, except with the proper a value. So that's what I'm going to attempt to do. So actually, it's a good thing that they gave us this other point here, because this other point indicates that when x is 2, y is equal to 5. We know it passes through this point. That's what it tells us. So all I'm going to do is I'm going to plug in this point into this formula to figure out my a value. So I know that when y is 5, I have a, and I know x is 2. So 2 minus root 3. And then over here I will have 2 minus 2 plus root 3. Okay, so this ends up being 5 equals a. And I know that 2 minus 2 is 0. So then I have negative root 3. And over here 2 minus 2 is also 0 plus root 3. So I end up with that. And so I end up with 5 is equal to, now I have negative root 3 times positive root 3, and that's, I'll do it the long way, but we should know that that's just negative 3. But negative root 3 times positive root 3 is negative root 9, okay? And so 5 is equal to negative, and then root of 9 is just 3, so this is negative 3a. That's actually a good thing, because now this is going to be a nice answer. Divide both sides by negative 3, and I get that a is negative 5 over 3. I say it's a nice answer because it doesn't have any radicals in it. So negative 5 over 3, that's my a value. So that's great, because now I have the full equation. That means that the full equation would just be y equals, sorry here, get my pen, blue pen here, so y equals negative 5 over 3, and then I have x minus 2 minus root 3, and then I have x minus 2 plus root 3. And that's, I would say, acceptable as a final answer, although final answers are never given in vertex form or factored form. It's always given in standard form. So I would, if I was you, I would try to expand this out to put it into standard form where you have sum a x squared plus bx plus c. How do you do that? Well, I would not worry about expanding this thing here. I would first expand all of this, all of these 3 items times all of those 3 items. The only way to do that is if you left this alone, You did x times every single thing. You did negative 2 times every single thing. You did root 3 times every single thing. You write that all over here and you add any like terms, and then you would multiply the negative 5 over 3 in that. So I challenge you to finish that problem and see if your answer is the exact same as the back, but this is acceptable. I'm good with this. So we're going to take a look at zeros of a quadratic function. So I'd like to take a look at page 185 before we start the review problem on this. But page 185, if you look at question 6, it asks us to figure out what value of k here would make this function have one x-intercept. Remember, in order to have one x-intercept, that means, and I know that this parabola is opening up because that's a 3, a positive 3, that would mean that it only touches the x-axis once. So it looks something like this. So the only way that it would touch once is if it had a double root. Okay, if any of you know what a double root means, it means two of the same thing, two of the same root. I explained it in my 3.6 lesson plan. That would mean that this thing's a perfect square trinomial. So basically, if you could figure out that number that would make that a perfect square trinomial, of course, that would be an acceptable answer. However, that's not the way the book wants us to do this, because there are more challenging problems later on that you need to know how to do it this way. In order for something to only have one x-intercept, we know that the discriminant, the b squared minus 4ac, which is underneath the square root sign of the quadratic formula, we know that that has to be equal to 0. If b squared minus 4ac is equal to 0, we know it has only one solution. Okay, so it only has one solution. We know this. If it was bigger than 0, it has two solutions. If it's less than 0, if it's a negative, it has no solutions. So to have 1, 0, we know that b squared minus 4ac has to be equal to 0. Okay, so if I plug in all my variables here, I mean, I know that my a value is 3, I know that my b value is negative 4, and I know that my c value is just k. So that's what I'll plug in here. So I have negative 4 all squared minus 4 times a, which is 3, times c, which is k, is equal to 0. Solving this, I'm going to get 16, and over here I'll have negative 4 times 3 times k is negative 12k equals 0. And now solving for this, I'll just bring the negative 12k to the other side, which will be 0 plus 12k. And so dividing both sides by 12 to get rid of that 12 there, I'm going to get that k is equal to, and I know that this 16 over 12 can be reduced. Both top and bottom are divisible by 4, so I will get 4/3. So k, in order for there to be only one solution, k has to be equal to 4/3. Now we did that question fairly quickly, but let's look at three questions after this. Number 9 on page 185. And number 9 states that the graph of this function, x squared minus kx plus k plus 8, touches the x-axis at exactly 1 point. Again, what does that mean to touch the x-axis at 1 point? I know that this parabola opens up because the a value is just 1. And so to just touch once, this is what the graph would look like. It just touches once. I'm not sure where that touches, but we are trying to figure out the value of k so that this parabola only touches the x-axis once. So again, what are the passable values of k? Well, in order for the graph to only touch the x-axis once, we know that the discriminant has to be equal to 0. That will give us one solution. Be careful here. Now, we know that my a value is 1. My b value is the number in front of the x, which is k, right? The a is in front of the x squared. The b is in front of the x, which is actually negative k. And then my c value is the constant at the end. It's not attached to an x. That's both of these right here. This is my c value, the k plus 8. So let's take a look at solving this to figure out what k is. So if I plug this in, I'm going to get negative k in for b, all squared, minus 4 times a, which is 1, times c, which is, remember, k plus 8. That's equal to 0. This is what I'm trying to solve. Well, just like the last one, I'll try to solve this. Negative k squared is negative k times itself, which is positive k squared. And then I'm going to have negative 4 times 1, which is negative 4 times k plus 8. So I have to multiply that out. Be careful here. This is negative 4 times both of those things. So this is k squared minus 4k minus 32 equals 0. And I'm trying to figure out k. Well, look at what happens here. What happens here is we end up with a quadratic. So in order to solve for k, we actually have to solve for this quadratic here. Now, there's two ways of solving for this quadratic. We can either factor, if possible, or if you're comfortable, or we can use the quadratic formula. So either one will give us the answer. I mean, the quadratic formula, when you plug it in, you get the answer immediately. Factoring, remember, I like to factor if it's possible. Factoring requires us to factor first and then find the zeros from the factors. So I'm going to factor using PSI because I know that this is just a simple trinomial. The product of this thing is negative 32 and the sum of that thing is negative 4. So two numbers that multiply to negative 32 and add to negative 4 are negative 8 and 4. They multiply to negative 32 and they add to 4. So one of my brackets will be k minus 8 from those two integers, and my other bracket will be k plus 4 equals 0. So we're not done yet because we know that this is the zero product property. This number in here times this number in here is equal to 0. The only way that can happen is if the number in there is 0 or the number in there is 0. So if the first bracket, k minus 8, is equal to 0, that means k is equal to, bring the 8 to the other side, and it'll be 0 plus 8. So k is equal to 8. From the other bracket, k plus 4, if that's equal to 0, that means k is equal to, bring the 4 to the other side, and it'll be 0 minus 4, so k is equal to negative 4. So k, in order for this to have only one solution, k could be either 8 or it could be negative 4. So let's take a look back at page 203, number 14 in your review. It says a rectangular field with an area of 800 meters squared is enclosed by 400 meters of fencing. So we know that the area of that square, or that rectangle, is 8,000 meters of fencing. Okay, so that's the area of that rectangle there. We also know that the perimeter is 400 meters of fencing because it's enclosed by 400 meters. So the perimeter, we know, is 400 meters. Okay, so perimeter is 400 meters. And so determine the dimensions of the field to the nearest tenth of a meter. Okay, so we have to determine the dimensions. I mean, it's telling us two different things about this rectangle. First off, it tells us the area. Secondly, it tells us the perimeter. So we're obviously going to have to make a comparison between the two. I mean, we know right now that this is the length. Let's call that length, and let's call this width. Okay, so this is the width, this is the length. We don't know what those lengths and widths are. We're going to figure out what the lengths and widths are. That's what they ask us for. So how do you find perimeter, right? Our first equation, if we are dealing with perimeter, just remember that perimeter is always equal to 2 lengths plus 2 widths. It's all the way around the rectangle. A width plus a length plus a width plus another length. So 2 lengths plus 2 widths. We also know that the perimeter is 400, so I actually can write down 400 is equal to 2 lengths plus 2 widths. That is true. That's what we know. Okay? Then on the other hand, how do you find the area of any rectangle? The area of any rectangle can always be found by doing whatever the length is times whatever the width is. But we know that the area of this thing is 8,000. So 8,000 is equal to whatever the length is times whatever the width is. So we have two equations and two unknowns. We have this equation, this second equation here, and we had this first equation here. We have two equations and two unknowns. I mean, last year, the way you figure that out is by either doing elimination or doing substitution. I mean, this equation here is all multiplication, whereas the other one is addition. So I'm not even going to get into elimination there, but I am going to substitute. See, what I'll do is I'll solve for one of the variables here. It doesn't matter which. And then after I do that, I'll plug it into that formula up there so that I can make a comparison. So I don't know, I'll solve for L because it comes before W in the alphabet. So if I leave the 400 on this side and I bring the 2W to the other side, I'm going to get negative 2W. Just going to rewrite that a little better. So 400 minus 2W is equal to 2L. Just brought the 2W to the other side. Then divide everything by 2, right? I'll divide this by 2, that by 2, that by 2. Getting rid of the 2 here. So when I do that, I'm going to get that length is equal to 200 minus W. So length is equal to 200 minus W. Like I said, you didn't have to solve for length. You could have solved for width. But now what I'm going to do, instead of writing length in that formula, I'm going to write this thing, the 200 minus W. Okay, so that's what I'm going to be plugging in here. So I have 8,000 is equal to the length. Instead of writing L, I will write 200 minus W times W. Okay, and now I'm just trying to solve this line right here. Okay, so once again, just like the really hard thinking problem at the beginning, I can solve this by multiplying everything out and then making the quadratic equal to 0. So if I multiply the W in here, I'm going to write this in descending order. W times negative W is negative W squared. W times 200 is positive 200W. And now bringing everything to one side equals 0. Actually, I'm going to choose to bring everything over to the left side. Why am I doing that? Because I don't like the fact that W squared is negative. The leading coefficient, I don't want it to be negative. I'm going to bring negative W squared to the other side, which is positive W squared. If I bring the positive 200W to the other side, it's negative 200W. And then I still have this plus 8,000 on that side equals 0. So this is what I'm trying to solve for. Now I can solve for that by either using factoring or I can use the quadratic formula. If it's not factorable, I'll use the quadratic formula. Otherwise, I'll try to factor it right now. And since I noticed it's not factorable, what I'm going to actually do is erase this whole thing so I can use the quadratic formula on this. W squared minus 200W plus 8,000. Okay, so I'm going to write out the quadratic formula here. I know that x equals, or actually I should write down not x, but W equals all of the rest of that. And I know that my A value is just the 1. My B value is clearly the negative 200, and my C value is 8,000, so I'll plug that in here. With the magic of this app, I can snap my fingers and get some more math done. And we end up with these two answers here. Width can be 144.7 or width can be 55.3. So what does that mean? All it means is that width can be either one of those two numbers. So we have two different numbers for width. So clearly, if we have two different numbers for width, we're going to have two different numbers for length. Remember, we know that length is equal to 200 minus 2W. So if we know that the first width is 144.7, we end up, after we do all this math, do this multiplication first, we end up that the length is 55.3. Interesting. So when the width is 144.7, the length is 55.3. Otherwise, if we plug in width is 55.3, we actually get that the length is 144.7. So all that tells me is it matters which side you call the width and which side you call the length. I mean, really the length doesn't technically mean the longest side, but what we do know is that these dimensions, the dimensions of this rectangle is a 55.3 meter by 144.7 meter rectangle. I'm not sure if your back of the book rounded this to 1 decimal place or 2 decimal places, but I rounded it to 1. So let's take a look at some of the problems from 3.8. So we'll start with the review on page 203. If we look at question number 22, it says the height h of t of a baseball in meters at time t seconds after it's tossed out of a window is modeled by the function h of t equals all that. A boy shoots a baseball at the baseball with a paintball gun. The trajectory of the paintball is given by this function. G at t equals 3t plus 3. Will the paintball hit the baseball? If so, when does that happen? At what height will the baseball be? So it's asking us, will this line, okay, I'm going to assume it does because it asks us a whole bunch of other questions after that. So will this line ever hit this parabola? Okay, so you have linear quadratic relationship here, and you're trying to figure out where the point of intersection is between the two. When will they be equal to each other? So when will the height of the baseball, h at t, be the exact same as the height of the paintball gun BB pellet, I guess? So when will these two things be the exact same? Okay, so we're going to try to figure out when those two things are the same. So I already know the formula for h at t. It's up there. It's negative 5t squared plus 20t plus 15. And I'm trying to figure out when is that equal to g at t. We know the formula for g at t is just 3t plus 3. So when are those two things equal? So how do I solve something like this? Well, you solve a quadratic by bringing everything to one side equals 0. I'm going to bring everything to the right side so that my negative 5t is positive. So if I bring this to the other side, it's going to be positive 5t squared. Okay, I'm going to bring the positive 20t to the other side, which will be negative 20t. I still have this 3t, this positive 3t here. I'll bring the positive 15 to the other side, which will be negative 15. And I still have this positive 3 over here. So I'm actually trying to solve 5t squared minus 17t and 15 plus 3 is negative 15 plus 3 is negative 12. So technically I'm trying to solve for time over here. At what time does this occur? Now, of course, we could just pop this thing into the quadratic formula, and the quadratic formula will give us our two solutions. Maybe only one of them makes sense. We don't know. But I am going to try to actually factor this thing. Now, I think it's factorable because I'm looking at the numbers here. This is a complex trinomial, so I will use the crisscross method. Two numbers that multiply to 5 are 1 and 5, and two numbers that multiply to negative 12, I'll say is 3 and negative 4. And so if I crisscross, that times that is 3, that times that is negative 20. Add them together. Actually, I got it on my first try, lucky enough, negative 17, which is what I wanted. So now disregarding the crisscross and reading straight across, I have 5x plus 3 as one of my brackets, and I have 1x minus 4. Now I wrote x's, but I should write t's. So fixing those, I have 5t plus 3 and t minus 4. Now remember, if you chose to factor, now you have to look at the zero product property. you have two brackets multiplied by each other equals 0. Either the first bracket is 0, the second bracket is 0. If the first bracket, 5t plus 3, is equal to 0, that means that 5t is equal to negative 3. Divide both sides by 5, and I'm going to get that t is equal to negative 3/5. Now, I'm going to assume that this is inadmissible because there is no such thing as negative time happening. This didn't hit the BB gun, paintball gun, whatever you want to call it, didn't hit the baseball at minus 0.6 seconds ago. From the second bracket, however, I got t minus 4 is equal to 0, which means that t is equal to positive 4. So I know that these two things are equal to each other at time equals 4. That's when they're going to hit each other. It asks us for what time this happens. When or will the ball hit the baseball? I mean, the answer is yes, it will hit the baseball because we got an actual answer that makes sense that is in the positives. So yes, it'll hit the baseball. If so, when? Well, it's going to hit the baseball at 4 seconds. But at what height will the baseball be when they hit each other, or when the paintball hits it? Well, this is where we can use any of these two formulas to figure that out, because remember, we are trying to figure out when those two are the same. So they're the same at time equals 4. So I'm actually going to use the second formula because it looks a lot easier than the first formula. So if I plug in a 4 in for time, I'm going to get, this is 12 plus 3, which is 15. So, and it didn't matter if you plug it in there, you're still going to get 15. So when will these two things hit? They will hit at 4 seconds at the height of 15 meters. So yes, they do hit each other, and they hit each other at the height of 15 meters at 4 seconds after the baseball and the paintball were launched. So let's move on to last question, number 23 on the review. Will the parabola defined by f at x equals all this intersect the line g at x equals that? Justify your answer. Okay, so what we want to do is we want to know, will they meet? Will they intersect? It doesn't ask us where do they intersect. Will they intersect? Yes or no? That's all it wants us to know, but we have to justify our answer here. So justifying our answer is not actually finding out the point of intersection like the last one. It is just justifying it with as little work necessary, I would say. So in order to find any point of intersection, we are trying to find when this parabola is exactly the same as this line. We're trying to find when they're equal to each other. Okay, so I know that the parabola, the formula of the parabola is x squared minus 6x plus 9. And I know the formula of the line is negative 3x minus 5. And so I'm just solving this. So I'm going to bring everything to one side equals 0. So I'm going to have x squared minus 6x. I've opted to bring everything to the left so that the x squared's positive. If I bring the negative 3x to the other side, it's positive 3x. Then I have a positive 9. Bring the negative 5 over, it's positive 5 equals 0. So I end up with x squared minus 3x plus 14 equals 0. This is what I would solve if I actually wanted to find the points of intersection. Remember, you had questions that looked like this in your textbook for the zeros of a parabola. When you're trying to solve this, you're trying to find the zeros. Remember when it asks us how many zeros are there? Is there 1 0? Is there 2 zeros? Or are there no zeros? The way you would find out if there's any solutions to this is all you would have to figure out is what the value of the discriminant is. That's all you really technically need to figure out. We don't need to find out what the answers are to this thing. We just have to know if there are answers. Are there answers, yes or no? So the discriminant will tell us if there are answers. if this number is 0, there's one answer. If this number is equal to any positive number, there are two answers. And if the number is a negative, then there are no answers. So we're going to plug this in. So let's see what happens. B is -3 over there. Okay, so that's my B. -3 all squared minus 4 times A, which is 1, times C, which is 14. So I end up with 9. And -4 times 14 is -56. And so this equals -47. So since the answer is -47, there are no solutions. So there are no solutions to that. Or obviously there are no solutions to this. These two things will not meet each other. Now question B is very interesting actually. It says change the slope of the line so it will intersect the parabola in two locations. Well, there you have it. Unit number 3, quadratic functions review using the Explain Everything app. Hopefully this video was helpful. Leave your comments below. I'm the math coach saying thanks for watching and see you next time.